This is the fourth and final video on how to interpret your NMR spectra. Step 1, count the number of peaks so that you know how many chemical environments there are. There's 1, 2, 3 peaks, which means 3 chemical environments. Step 2 is to look at how high the peaks are integrated and also how much they're split up into. This downfield peak on the left here is a septet and it's only 1 hydrogen. The fact that it's a single hydrogen that's so downfield tells me that it could be a hydrogen bonded to the carbon that's in the double bond with the oxygen, which would make the molecule an aldehyde and not a ketone because the functional group is on a terminal carbon. However, you have to combine the information about the integration as well as the splitting. So it is only 1 hydrogen, but it is split into a septet. The fact that it's split into 7 and has 6 neighboring protons tells me that it's a hydrogen bonded to a carbon, and that carbon is bonded to 2 methyl groups because each methyl group will have 3, so 2 methyl groups will have 6 hydrogens. This second peak at 2 parts per million, there's 3 hydrogens integrated and it's only a singlet, which means that it's probably a methyl group and it doesn't have any neighboring protons. That tells me that this is a methyl group that's directly bonded to the carbon-oxygen double bond because it doesn't have any neighboring hydrogens. This peak at 1 parts per million is so upfield compared to the rest, which means it's furthest away from that electronegative oxygen. It's integrated to 6 and it's a doublet. The fact that it's integrated to 6 tells me that it's 6 hydrogens from 2 methyl groups, which works perfectly well because those are the 6 neighboring protons that cause this septet over here. And the reason why it's split into a doublet is because it has 1 neighboring proton, which caused this signal. So combining all of this information together, you get this structure as your final answer.